It's a 21st century reality that environmental concerns have had an impact in all areas of the U.S. economy, including agriculture. Environmental awareness has created increased consumer interest in locally grown, sustainable food production. While advances in technology continue to improve farming productivity and efficiency, it still requires a large amount of two very precious natural resources, water and land. However, there is a sustainable, financially viable food production system that utilizes approximately 2% of the water use of a conventional farm. This system combines fish farming and hydroponics to create a symbiotic environment known as aquaponics. Aquaponics brings together the practices of aquaculture, raising fish in tanks, with hydroponics, the practice of growing plants in a soilless environment. In an aquaculture system, waste accumulates in the tanks, which eventually has to be removed to maintain the health of the fish. This byproduct contains rich nutrients that plants filter out, which allows the water to be recycled and sent back to the fish tanks to start the process all over again. An aquaponic system is scalable from small individual use all the way up to a large commercial operation. An initial investment for equipment can range from a few $1,000s to several thousand, depending on the size of the operation. Keep in mind, for every gallon of water in your fish tank, you can have 1/2 to 1 square feet of grow bed space, depending on fish density and feeding rates. And for every 1 pound of fish to be raised, you need 1 to 2 gallons of water. The fish farming aspect of aquaponics is based on the eco-friendly recirculating aquaculture system. A recirculating system is an indoor system that allows for careful control of the fish's environment year-round. While there are economic advantages of not being affected by the outside elements, there is a higher initial investment of equipment than there would be for cage or pond farming. In the recirculating system, all proper fish husbandry practices apply. Water quality needs to be maintained and carefully monitored. Consistent testing of water quality is a must to keep the fish healthy and disease-free. Access to water and reliable electricity is crucial for success. Even though the water is being recirculated, runoff and evaporation will occur, and the water supply will need to be occasionally replenished. Electricity or some sort of power is necessary to keep the fish tank at the ideal temperature and run pumps to circulate water back between tanks. This type of optimal condition allows for a fast-growing stock that is less susceptible to disease, but regular observation is still an important factor in maintaining fish health. Any behavioral changes, particularly during feeding, is an indicator of problems. The feed you use will be determined by the type of species you choose to raise. But whichever feed you select, it must provide a complete diet and be of the floating variety. An auto or demand feeder is frequently used in the recirculating environment. Even though the feeding process is automated, you still want to be present to observe feeding behavior. Tilapia is the most common species raised in the recirculating system because of its large size, rapid growth, high densities, and hardiness. Perch, hybrid striped bass, trout, and catfish are also known to do well in the tank environment. Each species of fish is going to have their own set of guidelines for proper feed amounts. Harvesting the fish will be determined by the individual species' growth cycle. Be sure to practice proper fish handling in the harvesting and transportation of the fish to the market. For additional guidance, watch this online video or contact your local county extension office for additional guidance. The key component to the recycling aquaculture system is the removal of the harmful waste products and uneaten food from the rearing tanks while continuing to recycle the water. Instead of disposing of this material, which you would do in a strictly aquaculture system, the practice of aquaponics utilizes the fish effluent in the growing of plants in a hydroponic setting. As the waste and uneaten food collect at the bottom of the rearing tanks, it exits by way of a PVC pipe to a clarifier or settler. A clarifier or settler is where the anaerobic mineralization of the waste and uneaten food occur. Over time, the waste material collected in the clarifier begins to break down and releases nutrients to the water. Trace materials such as iron may have to be added to supplement the plant's nutritional needs. This mineral-rich water then moves through the biofilter. A biofilter allows for the natural biological process called nitrification to occur. Through the breakdown of the waste, large amounts of ammonia are released in the water. The natural bacteria present in the water will use the oxygen in an aerobic process to efficiently convert the ammonia to nitrite and then to nitrate. The biomedia in the biofilter expedites the process by allowing the bacteria to colonize in an area with correct water temperature, pH, and dissolved oxygen levels. This nitrate-rich water then moves to the plant grow beds. The grow beds can be a soilless environment, or they may be using a growing medium like perlite or ceramic stones. The plant's roots are immersed in the water, absorbing the rich nutrients while simultaneously filtering out the nitrogenous compounds that are toxic to the fish. Within the hydroponics discipline of aquaponics, there are a few different growing methods that you can choose from. Deep water raft aquaponics uses styrofoam mats to secure the plants in a trough of water. The seedlings are placed in net pots with a planting medium like cocoa peat, a material from the outermost shell of a coconut. Cocoa peat stimulates and protects root growth but contains no minerals. The plants can be grown to maturity in net pots or can be removed from the pots in growing medium after a couple of weeks and placed in a different floating mat to maximize space in the grow beds. Plants can also be grown in a solid medium like gravel or perlite. The aquaculture water floods the grow bed containing the plants and growing medium. This type of system is known as recirculating aquaponics or closed-loop aquaponics. A common growing medium used is perlite. Perlite is a volcanic rock that provides superior root growth by absorbing the nutrient-rich water and keeping the moisture level constant and consistent throughout the plant's root system. Depending on the growing technique, there are several medium options to choose from. Seek out all available literature and contact your local extension office for additional guidance. Water is only half the equation when it comes to plant growth. The other, of course, is light. Your lighting needs will depend on the location of your aquaponic system. In the Midwest, where systems are indoors, artificial lights will be necessary. There are several types of lights that can be used depending on the budget and application. High-output fluorescents are commonly used grow lights. It's a cost-effective option with the added benefit of having a low heat output. This allows for very close light placement, which provides for maximum plant growth. LED grow lights, while much more expensive than fluorescent, usually 2 to 3 times the cost, are more power efficient, have longer lasting bulbs, and have the flexibility of adjusting the light spectrum. Red light is more desirable for budding plants, while blue light works better for vegetative growth. It's possible to mitigate the cost of LED lights by installing a track system above the grow beds. and reducing the number of light fixtures needed. Obviously, there's a trade-off. The growth rate of plants under a constant source of light will be faster than a grow bed utilizing the track system. Metal halide lights are also used in an aquaponic system. These grow lights put out an intense amount of light high in the blue spectrum. The individual bulbs can be expensive, and they do produce a considerable amount of heat, so you need to be sure that your space has proper cooling and ventilation. Metal halides are best for large plants, while fluorescents do better with small, leafy plants. Also, you want to avoid using metal halides on seedlings due to the intensity of the light. Grow lights can be used as a sole source of light or combined with natural light in a greenhouse environment. A greenhouse provides economic advantages by reducing the amount of artificial light required. Like selecting the species of fish, choosing what plants to grow is an important decision that affects infrastructure and business planning. Leafy greens like lettuce and cabbage, and herbs like basil and oregano do well in an aquaponic system, but any common garden vegetable can be grown. Careful consideration must be given with plant selection because in an aquaponics operation, the plant side tends to generate more income. Study the markets and choose plants that will bring the largest profit margin. Focus in on markets that will pay a premium for organically grown vegetables like farmers markets and stores that specialize in natural and organic food. Packaging your own product is also an option. For more information on plants, seek out additional literature and contact your local extension office for guidance. As the water moves through the grow bed and the plants pull out the nutrients, the filtered water flows from the bed to the lowest point in the system, called a sump. From there, the water is pumped back into the rearing tanks and the cycle continues. Some micronutrients, such as iron and magnesium, may need to be added to the system to ensure plant health. Aquaponics reduces the environmental footprint in crop production and allows for cultivating plants in locations you don't typically associate with farming, from a windowless basement, to a remodeled urban townhouse, to a retrofitted factory building. As long as there is access to electricity and water, fish and crops can be raised in this indoor, eco-friendly, symbiotic environment. However, with the ability to raise fish and grow plants indoors year-round, a major issue to consider is the energy costs associated with heating and air conditioning. HVAC is one of the biggest expenses in an aquaponics operation. Making sure the building is well insulated will cut down on this cost. Water temperature needs to be maintained for the health of the fish, and room temperature needs to be regulated for plant growth. Each aquaponic system can be designed to maximize the use of available space. A room with high ceilings can allow for the stacking of grow beds. This will require more pumps and plumbing, but the investment will allow for more plant production. Utilizing natural light from existing windows in an old factory building can also help by reducing artificial lighting costs. With careful planning and caretaking, aquaponics can not only be an eco-friendly, sustainable food production system, but a profitable business with significant growth potential. This video has provided an introduction into aquaponics. If you're thinking about starting your own operation, seek out additional information on the web and/or contact your local extension office for guidance.